The milling machine is used to make precision cuts, hole patterns, pockets, and slots in a variety of materials. While parts produced on the mill are generally rectangular in form, angled and circular cuts can be made with optional attachments. The milling machine has a number of components the operator must become familiar with. Let's identify the parts. Power switch, motor, column, belt cover, height adjustment crank, head lock handle, belt tension thumb screw, base, saddle, table, vise, feed crank, quill feed handle, quill, Z-axis fine feed crank, quill lock, and depth gauge. This milling machine is of the round column variety, where the milling head can move up and down in the vertical direction. Larger milling machines may be of the knee variety, where the head remains stationary as the table moves up and down. The milling machine features 3 axes of motion. The x-axis extends from left to right, the y-axis from front to back. The z-axis extends in the vertical direction. Each axis has a positive and negative direction. The positive x-axis is located to the right. The negative x-axis is located to the left. The positive y-axis is located toward the rear of the machine. The negative y-axis is located closest to the operator. The positive z-axis is in the upward direction, while the negative z-axis is in the downward direction. Using the milling machine requires a variety of tooling. R8 collets are the industry standard for manual mills. Collets are installed to the machine's spindle and are used to hold cutting tools such as end mills. Collets are offered in a variety of sizes, ranging from 1/16 of an inch to 7/8 of an inch. Choose the proper size collet for the end mill or cutting tool you have selected. End mills are the primary cutting tool used in the milling machine. While similar in appearance to drill bits, end mills are designed to cut sideways rather than downward. This set of end mills features 2 types, 2-flute and 4-flute. 2-flute end mills are used in softer materials such as aluminum. 4-flute end mills are used in harder materials such as steel. The face mill features a solid body and several indexable carbide inserts. It's designed to remove large amounts of material in a single pass. Parallel bars come in matched pairs and are precision ground to close tolerances. The step block and clamp set is used to hold larger workpieces directly to the mill table. Sets are commonly available in height increments of 1/16 or 1/8 of an inch. This milling machine features a 12-speed belt drive, with speeds ranging from 85 to 2,225 rotations per minute. Slower speeds are used for larger tools and harder materials, whereas faster speeds are used for smaller tools and softer materials. Before changing belt speeds, ensure the machine is unplugged or disconnected from the electrical circuit. To change belt speeds, begin by releasing the belt cover latches. Remove the belt cover by lifting it over the machine's column. Release belt tension by loosening the thumb screw, pulling the motor forward, and retightening the thumb screw to hold the position. Next, release intermediate belt tension by loosening the 2 hex bolts on top of the machine. Remove the front drive belt by working it from the larger step to the smaller step on the pulley until it is freed. The intermediate drive belt can now be easily removed. Reinstall belts according to the diagram on the front of the machine. First, place the belt in the lowest position, followed by the belts in the higher positions. When reinstalling the belts, ensure they are placed on the proper set of pulleys, as each of the 3 belts is a different size. Retension the belts by pushing the step pulleys toward the rear of the machine. Retighten the hex bolt to hold the position. Ensure the belts are properly tensioned. Retension the last belt by loosening the thumb screw, pushing the motor toward the rear, and tightening the thumb screw. Check for proper belt tension. Reinstall the belt cover and secure the latches. The belt speed adjustment procedure is now complete. To remove the tool from the spindle, some machines feature a spindle brake. However, this mill needs the cover removed to hold the pulley. While holding the tool gently in one hand, tap the drawbar downward, releasing the collet from the spindle's taper and freeing the tool. Further loosen the drawbar by hand to remove the collet from the spindle. When loading a tool to the machine, ensure the keyway in the collet is aligned with the key in the spindle. When properly aligned, the collet will not rotate by hand. Push the collet into the spindle and load the tool into the collet. Tighten the drawbar. Loosen the two hexagonal nuts clamping the milling head to the machine column. Loosen the clamping handle. Rotate the height adjustment crank to lower the milling head to the tallest height anticipated during the milling operation. Securely tighten the two hex nuts and handle, clamping the milling head to the machine's column. Ensure the vise is clear of chips and debris prior to setting up the workpiece. Keep the cutter positioned to the side of the workpiece to avoid plunging downward into the material. Rotate the X or Y axis feed handles to produce a cut in the desired direction. It's important to maintain a smooth, consistent rate, as this ensures proper chip formation and surface finish. End mills can cut using either a climb cutting or conventional cutting strategy. In climb cutting, the direction of travel is the same as the direction of rotation. In conventional cutting, the direction of travel opposes the direction of rotation. Climb cutting is preferred over conventional cutting as it produces a superior surface finish. However, it requires a machine with rigidity and minimal backlash in the lead screws. Here we are using a climb cutting strategy to face the surface of the material. The mill can also be used to produce slots. However, the feed rate must be reduced due to the increased engagement of the cutting tool. The width of the part can be reduced by milling on the sides. Set the zero reference point by gently touching the cutting tool to the side of the part. Next, move in the desired amount before proceeding to cut the edge. Release the quill lock and turn the Z feed wheel to move the end mill down until it barely touches the top of the workpiece. This sets the 0 position. The Z-axis features a 0 resettable dial. Using a hex key, loosen the set screw. While holding the wheel to prevent it from rotating, turn the dial until the 0 mark aligns with the indicator scribed in the crank housing. Re-tighten the set screw. The 0 height position is now set. With the right tooling and extensive practice, the skilled machinist can use the milling machine to make a variety of high-precision parts to close tolerances. Which part of the machine allows setting a reference point for measurement? A. Quill feed handle. B. Height adjustment crank. C. 0 resettable dial. D. Tension adjustment thumb screw. The correct answer is C. 0 resettable dial. Thanks for watching, and we'll see you in the next video.